Hi, I'm Terry VanNoy. Thanks for watching this video. This is Math Class with Terry V. This is a viewer challenge, and when I show a viewer challenge, it comes from questions that I get from other viewers and students who watch these videos. Now, if you want to work live with me, I would love to work with you, as I do with about a dozen clients right now and growing. And it's totally online and remote, and just like we're talking right here, I can answer your specific questions and give you some support for what you're learning in your classroom. So give me a call or go to my website, and the first lesson is free when I show you how it all works. Now, viewer challenge number 2 here for special right triangles. That's what we're talking about. 30, 60, 90 triangles and 45, 45, 90 triangles. All right, get a piece of paper, and I want you to give this a try. So what I have here is a parallelogram. Now, I know the top base here is 24 inches. I know that the bottom base here is split into 2 separate parts. Notice that height right there, sometimes called an altitude. And that breaks it up into an x part and a 3x part. And we know this angle is 120 degrees. So here's the question. What is the area of this parallelogram? All right, click on pause and give it a try. The area of the parallelogram, you need to remember that formula is base times height. All right, very similar to the area formula for a rectangle. So I always think of a parallelogram as a slanted rectangle. All right, the base here we know is 24, so that's not a problem. But now we need to find the height. All right, now the height here is h. We can also think of it as this distance here. Okay, it's going to be the same in either direction, but we have to take the principles and the properties of the angles and the sides of a parallelogram to figure this out. Do you have it already? All right, well, keep tuned. Let's figure this thing out. Now, if this is 120 degrees, then I know that this has to be 60 degrees, right? All right, 60 degrees there and also here. All right, also if you remember opposite sides, or excuse me, consecutive interior angles here of a parallelogram have to be supplementary. So that means if this is 120, that has to be 60, and this has to be 60. They have to add up to 180. That's probably a quicker way to figure it out. But the key here is that this triangle here or this triangle, same thing, are 30, 60, 90 triangles. So because we need to know what the height here is to find the area of the parallelogram, we're going to have to use that, what we know from a 30, 60, 90 triangle. Well, hopefully it's obvious here that we have to solve for x. I know that these two parts together make 24. So let's go ahead and solve for x by saying the x part plus the 3x part must equal the 24 inches at the top. Okay, opposite sides parallelogram are always the same length, right? So when we solve this, of course, 4x would be 24, and x, when we divide by 4 there, x has to be 6. All right, well, that's the first thing we figure out. We know that x is 6 inches. Now, given that, can we figure out the height? Yes, we can. Remember that the short leg, 6, if we multiply by radical 3, that will give me the longer leg. Okay, that's sort of a property or a principle of being a 30, 60, 90 triangle. So short leg is 6, long leg is 6, radical 3. Now we just continue this by saying the base is 24, and we know that the height is 6, radical 3, and we're going to multiply the 24 times the 6. That's going to be 144 radical 3. All right, now if we keep it in radical form, that will be the exact answer. If we are asked for the approximate answer, then we find the decimal value of radical 3. We'll have to round it a little bit and get the answer that way. But this is the exact answer, 144 radical 3. All right, so I'm tying in a little bit of some parallelogram information plus 30, 60, 90 triangle working with radicals. Thanks again for watching, and share this with others if you think they would like it.